I'm wondering if I should explore a career in space.
On the first day of work, I realized they all need satellites. And that was the day I also realized that I will eventually go back to space. Every company would be a space company eventually in the end, because there's always that relevancy to space. You just can't avoid that. And it's just a matter of time that in the end of the day, you will have to deal with us. I think space education is fundamental to any individual's existentialism, their perspective in the world. There's no planet B so far as we know it. Even if there is, we can get there. It's just at the moment we don't have a choice except Earth.
When we talk about going to space or living there or making it habitable or all of those things, they sound so far-fetched. Is it really going to happen? Hi everyone, welcome to She Talks Business, another episode from Bali. This is a very, very exciting episode for me because it's all about the space economy, which has been a growing interest for me, but one that I have not been able to explore too much so far. So I'm super happy to have you, Anna. Thank you so much for being on the podcast.
Thank you for inviting me. It's a pleasure. It's an honor. Thank you for considering me as your guest.
Awesome. I want to start with, you started in public-private partnerships. You have a bachelor's in a completely different domain. We'll talk about that maybe if we get the time. And you've landed in space, space education and advocacy. Walk me through, how did you end up building an organization on space education and advocacy?
Okay, so that's not going to be a linear answer because that's spanning over, I guess, 15 to 20 years. But I've always wanted to work for NASA since I was in high school. And my late father is an aerospace engineer as well, but he was more of an aviation guy. So I've always had that aspiration to work in space since high school. But, life happens. I didn't get to study aerospace engineering, and little did I know that you don't need to always be an aerospace engineer to work in space. That I know now, and look where I am now. But the journey, it was it wasn't linear at all. So when that didn't happen, I ended up doing arts and then studying, I've always liked science though. So I still kept that as part of my philosophy of science, degree. But then how life turns out that after even I studied humanities, arts, religion, I ended up working in an engineering firm. And that just builds up my career in the engineering field. And so from infrastructure to master planning, urban development, I shifted to defense and military. And a huge part of it is obviously maritime. And at that time, in 2013, 2014, maritime security was a huge discussion, especially for us in Indonesia. And that's the first time I learned about radars and synthetic aperture radars as well, monitoring maritime through satellites and as well as ground systems. So that indirectly brought me to aerospace technology. And I ended up working for one of the biggest defense contractor in the world. It's a U.S. firm. So that then set me into aerospace eventually. But because they did business in Indonesia and there's not many space activities here, we heavily concentrated in defense. So I shifted from defense and military to environmental and forestry and peatland and just deforestation, stakeholders management, etc. And to the extent of, on the first day of work, I realized they all need satellites. And that was the day I also realized that I will eventually go back to space.
Wow.
So it was a good detour, climate change, knowing your stakeholders, and a non-space technology that actually to know the state of the planet, you all need space technology. You need satellites. So, and also obviously that's main purpose of having satellites for national security, defense purposes, right? So I knew it also from there on that like, okay, I'll be back in space. So after some experience in that sector, in that industry, I decided like, oh, I think space is important. Not only that, again, for satellites, for connectivity, or for observation of the planet. There's all of the derivatives from aerospace technology that's highly useful for our lives here on Earth. So I've been a strong advocate of space since a decade ago, and I was encouraging my friends to start a business in space, and they're just kind of like, they're not really interested in it. I'm like, okay, I think I'm gonna do it, and they're like, you're crazy, and I'm like, maybe I am. So that was the start. And I thought Indonesia don't really, I mean, we were leading at one point. In the very beginning, we were the third country to have like a geostationary satellite for connectivity. And then we were the first one as well to have an observatory in this region, actually. Oh, wow. So we were leading back then, and then suddenly it stopped, right? So yeah, I mean, that journey started a decade ago. But what I'm advocating now is bigger than that. It's more wider. It's for the entire industry, from not just research, as well as industry, but also for exploration in general. So just the whole space spectrum. Yeah. So
that sounds so exciting. Like your entire journey of how you landed where you always thought or you wanted to be. Right? It was a detour, but. Yeah, but ended up there.
Now I look back that if I had not made all of those detours, on the journey, you got really confused. Especially my friends. Don't ask about my family. They'll go like, what is she doing now? But now that I look back, it's like, if I had not done that, I wouldn't be able to understand space as it is today. It's because of all of those experiences. My experiences in infrastructure now is highly relevant to lunar construction. Right. So, setting up the lunar base, master planning the lunar base, like where's the first settlement on the moon going to be? So it's that's because.
Are we thinking about that?
Well, yeah, they are doing it. They're planning for it, and they're doing the geotechnical engineering work at the moment. There's like working groups by the John Hopkins University and Applied Physics Laboratory, and it's being led by a company called, I don't know if I can mention this, but it's a U.S. firm of which I used to work for,
right,
for the Indonesian office. So it's interesting how I could have a Zoom with my former boss and our colleague in the US, and we were all he's still working that company there in the US, but we used to talk about master plan here in Indonesia, and now we're talking about master plan on the moon.
Wow.
So had I not have that experience in engineering firm, terrestrial, for infrastructure and urban development, I would not be able to understand the complexity of constructing a lunar base at the moment. So all of that master planning, and that's highly useful for me to understand. Plus all of these planetary science, where obviously building on the moon is completely different from building here on Earth, right? So then it gets more complex. Then you learn more, because the gravity or atmosphere and regolith, it's different from drilling here on Earth.
Yeah.
So all of those knowledge in terms of building a power plant, or how you're going to be self-sustaining in terms of energy over there, right? So all of that I learned during my detours.
Wow.
Including even, for example, satellites, like Earth observation satellites. And I specifically know who are the stakeholders who needs it, and whether it actually answers the question, and whether actually it works, or the business model works or not, So it's very different when you're producing innovations of technology and actually trying to solve the problem. And that's where we try to to be at, you know, to bridge between the problem and the technology, whichever comes first. Because sometimes the engineers would come up with the innovations of technology, but does that actually solve the problem? Because what they need is completely different and it's not applicable, right? Sometimes it's not the most sophisticated technology, but it's like a simple technology that could solve the problem,
Right.
and there's always the human factor and political will, or etc. Regulatory policy that's not, that you cannot solve. Technology cannot solve that. That's all the human and social factors. So it's then it's interesting the play whether between the technology offered from, let's say, space and to how it can help us solve, or you know,
Problems here.
On
Right.
Earth.
Okay, this is all very exciting for me. Let's first talk about what you do. Tell me a little bit about what you do at Antarexxa, and then we'll talk in more detail about the space economy itself.
Okay, so we are a space advocacy firm, and focusing at the moment is in spreading awareness of what space industry is. Because majority, especially in emerging countries like us here, right? So we try to bridge between the spacefaring, these countries who are leading in space, have space industries, they have regular space activities, they have a space program, and those who are committed to go to the moon, and they have the entire spectrum they want to build, but they don't have access to talent pools, and the industry needs to grow, right? So for us in emerging countries who do not have that access of education, for example, and then don't have a solid space program, not the entire spectrum anyway. So we try to bridge it together in a way that, like, look, we have a lot of talents here that are interested in space, and we can grow. We can grow the market as well here, and we can utilize this talent pool for the global, for the local, and for the as well as the global ecosystem. The opportunities are there, and so that hopefully by having multicultural, you know, diversity, it will help the industry grow faster, more rapidly, as more people try to solve these complex challenges in space, because space is hard and it requires a lot of problem solving from multi-angle, multidisciplinary, right? And it's not just from one nation, but it's multi, and it's international cooperation. Like, for example, the ISS, that's over 20 countries building a structure in orbit for the past 20 years.
Right.
So that's the same thing. Like, you can't go far, you have to go together, right? So that's also the very good philosophy out of space industry. You know, it's an international cooperation. Like, maybe in other areas, countries have dispute, but in space we can cooperate together, and countries are exchanging, you know, like they're working together, whether to innovate on technologies or trying to work out a policy, for example, for space sustainability. And yeah, I mean, it's the ISS is still intact, and although it's gonna get decommissioned soon, but that's proof of how, if we all work together, we can reach beyond. So,
and there's the will to also work together when it comes
obviously
to space, right?
it's space has always been a government game, right? There needs to be a political will from leaders of the country to go to the moon tomorrow or go to Mars, right? And you need someone like Elon to lead the pack and like, we're gonna do it, and he's putting the work in, and he's demonstrating it, reaching the targets, and which nobody ever expect, right? So but as one person could really change the game. So is leaders of the world, right? So if we all unite and say, okay, we want to reach further, that's where the commitment is. And you don't want to miss out on that, honestly, because that's a lot of innovation, that's a lot of science, that's a lot of knowledge, and that's a lot of advancements for not just space, but technology all across.
Right. Okay. Tell me a little bit about, like, as a layman, when I think of space or the space economy, I think of satellites and all of those things. But can you break it down for me in terms of what is the space economy? What does it entail? What does it encompass? What are the different verticals maybe within space? What is the size of the space economy? I know we hear these big numbers. Tell me a little bit about what the space economy entails, and then we'll dive deeper.
Okay, so space economy, like any other economy, will consist of upstream, in-stream, midstream, downstream, right? And how we divided it in space is when it comes to upstream, that's all the space infrastructure.
Right.
It's all the heavy hard tech, engineering, launchers, rockets, space stations, spacecrafts, rovers, all of these hardware technologies that require huge capital investment, technology build up throughout time. You need top-notch, deep pocket investors, governments sustaining the program, because we, for example, like a launcher or a spacecraft or space stations, right? Like that's not going to go over 10 years. So that's a huge entry barrier, cost a lot. That's where all the infrastructure is being set up. That's access to space. So then there's also the in-stream, which means like in orbit space stations that you're trying to make space hotels or some pit stops. All the cislunar space, which is cislunar is a region between the Earth and the Moon, and that's like the next big thing in terms of lunar commercialization of space. So there's a lot of infrastructure over there as well, right? You need to make hotels or logistics or like warehouses, and then refueling and many different infrastructure sustaining that as well. Communication system, lunar Wi-Fi. There's the midstream where it's practically like ground stations. So all of the infrastructure here on Earth that's supporting it. Once you have, let's say, the satellites on board in orbit, and then you have all the data streaming down, and you have the ground system and a ground support, where you will then distribute it to stakeholders, right? And then there's the downstream where it's all the applications. So what are these data used for? If it's GPS, or navigation system, those are like customers, right? And the applications of satellite data imagery would be useful for defense, national security, for climate change, and also navigation, for example, maritime shipping. So that's applications. That's the applications so far of the technology, and that's very downstream. So it doesn't need a lot of capital investment as much as, if you want to build a space infrastructure or space assets, but it's a huge investment cost to maintain it, because it's like IT operating system and platforms. So the business model is more challenging in that way, because sometimes the market's not matured yet, or you have very niche market that the return of investment is just still not there yet. It's either you wait for the market to be more mature, or it's just not the right business model, and they continuously need to find, because that's the downstream challenge. But that's space economy in entirety, and that's industry as well. But at the same time, there's also the research for the academia. Whatever knowledge you produce from that will hugely also be beneficial for the technology innovations, right? Like, and as the trend grows, it has to be multidisciplinary, because again, there's the heliophysics, there's the sun affecting the solar storm, and all this space weather affecting all of these spacecraft in orbit, or when you want to launch a missile and then you catch a solar storm and it doesn't hit the target and it's elsewhere, that's bad news for any kind of armed forces in the world. So the economy is wide range. Industry, of course, sustain it all, but in terms of knowledge, whether academia and also exploration, that's where all of the innovation of technology, giving birth to things that are not been done yet, creation of technology, innovating technology, or also integrating it with another. So that's the technology spin-offs that is also applicable for other industries, or it has its dual use for our terrestrial business here, as well as it solves planetary challenges. So that's a whole overview.
I'd love to know a little bit more about, I think, at least for me, I've been hearing a lot more about the space economy recently. And we see that there's going to be X amount of growth in X number of years. And so it looks like everybody's projecting a lot of growth in the space economy and this industry. What do you think is really driving that growth? Why is it suddenly becoming so much more important? Why is there so much attention going there? Or is it just me listening to more people talk about space?
Obviously, the Big Four analysis and the latest report from World Economic Forum, they project about $1.8 trillion by 2035.
Right.
So last year is about 630 billion. So about 9% growth per annum. That's a projection. Space economy with, I think, the impacted non-space sector that's relevant to it. That's why the number is flaunted so huge, right? So it's not just within the industry, but it's also affecting all the non-space. So it's applications. Remember when I said when it's applications,
like Uber and
non-space sector. It will touch e-commerce or ride hailing. Navigation will affect shipping and etc. So space is the future. We can't deny that, right? It's coming, and everybody's especially now that a lot of people are working on it and they are committed in growing it. It's just a matter of when, right? So if you want to flaunt the numbers, yes, then obviously it goes beyond, but it's about timing as well. When's that going to happen? Right. So a lot of the investments at the moment are currently stagnant because there's still not much return. And a lot of the VCs don't have the return and they cannot reinvest back, right? And apart from all the geopolitical changes at the moment, but space relevancy to our everyday lives, especially in terms of commerce, is undisputable. We rely every day on satellite communication technology, whether it's GPS, navigation system, connectivity for phones, broadcast, TV, satellites. It's the entire infrastructure of space connectivity. Is if we eliminate that, does the economy melt down? So that's how relevant it is, and that's why it's impacting a lot of those non-space sector as well. So that's the relevancy. And to not forget all of the space exploration opportunities within that space economy potential, right? Of again the technology or the building blocks of it is highly again relevant to our terrestrial industries. For mining, for oil and gas, for example. If you even, you want to go renewable, solar panels, battery, that's all of the technology that we also need on the moon, right? Or in orbit, right? So, and that's how you can't avoid space and how that's highly relevant to whatever it is that we're doing here.
Yeah.
So every company should have a space policy, or every company would be a space company eventually in the end, because there's always that relevancy to space, right? you just can't avoid that. And it's just a matter of time that in the end of the day, you will have to deal with us. Because you have no, and the great thing about space is whatever your background is, there's a place for it in space. And that's how we could say that, like, of course there's the relevancy. There is a place for everybody in space.
Yeah, I mean, when we talk about going to space or living there or making it habitable or all of those things, like, they sound so far-fetched when I'm listening to you. They're all exciting. Do you think it's something that's going to happen in the near future? Like, what's happening? What are there new advancements that are happening that are making that possible? You mentioned we were trying to build something on the moon to get to Mars. Can you tell me a little bit more about, like, is it really going to happen? How soon should we expect for that to happen? We keep hearing these this news of these millionaires wanting to buy a piece of land in space and stuff like that. Is that going to happen sometime soon?
Well, the first and foremost is you can take a look at what SpaceX have done, right? And their company is valued at $350 billion as of today, and they're the leading one.
Yeah.
So you look at what SpaceX is doing, and they did like a few test flights of Starship, and everything seems to look okay.
Yeah.
And so judging from that, like, they're putting where the money in pocket is and the mouth is as well. They're walking the talk, and so I would also certainly believe and hopeful that maybe the 2026 mark is possible.
Oh wow, that's
the aim to go, right? And looking at the developments now, they look like they're on the right track. So, and then if you also want to look back on all of their achievements, like from Falcon 9 to Falcon Heavy to Starship and to now, they are literally on the right track. And if they have demonstrated so far, I certainly hope, I have that belief that they could probably make it by 2030, whether it's going beyond orbit, like going to deep space at least, or they are definitely going to the moon. The moon's like 3 days away. They can make it. Mars is a different scenario, but that's probably the benchmark.
Right.
If you ask me, like, what's going on in space and whether it's far-fetched or not, it's actually not really. A lot of my colleagues are literally doing Star Trek stuff,
Wow.
So
interesting.
Exactly. And when you're in that level as well, and you talk to all the space startups or the players, and it feels so far-fetched from our daily conversation here in Indonesia, for example. But when you know that there are companies being invested in doing all of these technologies and they're working on it, like, it doesn't seem science fiction anymore. And they're actually working on that, and the science is there and the technology is progressing, right? So that's why the industry needs to grow, and it needs more people, and et cetera, which will also bring us back to the talent pool acquisition and human capital development from many countries and different backgrounds, different disciplinary, because you need different perspective in solving this problem. But in your case of question, like millionaires wanting to buy land, I mean, you can do that virtually already. You can buy a star from Decade.
Yeah.
You can buy a star. My friend bought me a star, and you will always be able. It's like buying a domain, right?
Right.
So everything in the metaverse, like how are you going to quantify that?
Yeah.
But we're talking about hardcore deep tech, hard tech, and engineering. There's that concept and there's this vision of building a lunar base, but is the geotechnical engineering resonating with that plan? So if not, what needs to be done? And that's also, this is a new branch, even in the American Civil Engineering Society, as we know it of today, this is still a new discipline. So this is why it's very exciting for myself as well, and like the colleagues who are working on it, is because even in a community, in a working group of experts who are they've got like 30 years under their belt or 40 years under, like they're highly experienced seniors in geotechnical engineering and underground excavation and construction for, tunneling, whatnot on Earth. Even for them, this is something new.
Yeah.
Like the regolith, understanding how you're going to drill and what's the impact, what about the quakes on Earth, how are you going to structure it, and all of this. Even for the most senior geotechnical engineers, it's still very puzzling, and they still need more data. So it's decades of expertise on Earth being brought upon to solve this problem. Whether it's possible or not, we're yet to see, right? But prior to that, there's a whole database that we need to work on to conduct further feasibility study and et cetera. But it may happen in 10 years, it may happen in 20 years. We don't know, right? Again, if the political will is there,
right,
and if the talent sources are there,
right.
Again, a lot of these things in space, especially for exploration, going to the moon and Mars, it's still very, very new. It's very new. Space food, space medicine, space farming. But that's all rooted in agriculture, in agri-tech, biotech, food tech, which we all know already. Right? So now just adding it on the challenge. Okay, well, what if you plant this with a moon regolith? What if you plant this with a Mars regolith? And we have to study all of that, whether the structure of the plants, and is it edible? Is it harmful? Or that takes time. How you engineer, like how is it going to impact your blindness if you're in space for a long time? That's a lot of knowledge gain for even our medical field here.
Right.
So that's why space is fascinating, because it has a crossover with so many of our terrestrial sectors here.
Right.
They're highly beneficial.
Yeah.
Aging, radiation, cancer research, all these medical, pharmaceutical research that could be done in microgravity environment, that's highly beneficial, not just for space exploration, but also for us here. So if you ask me when, I have no idea, but it's happening. Right. Progressing every day, and it needs more people, it needs more researchers, scientists, technologists, programmers. It needs a lot of support as well to make it happen faster.
Right. Okay, so you've already sort of built the case or made the case for why it's important, how it impacts us here, but I want to talk more about, I want to understand a little bit more how, let's say, space exploration, for example, directly impacts businesses or industries here. Like, what should we know? Do we need to prepare for something? Are there specific industries that can benefit from space exploration? I remember during our call yesterday, you mentioned water filtration technology coming from space exploration. Like, what are some things that the world today here on Earth can benefit from all this space exploration and technology and so on and so forth? Like, you've talked about it in bits and pieces, but I'm super curious. Like, what do we need to know?
So in space, we call it the spin-off.
Right.
The spin-off technology. It is the investment stack. That's why people invest in space, because it's all the knowledge, science, and whatever innovation that you found on the journey there. That's what beneficial and applicable for our for our terrestrial and non-space industries.
Right.
So, for example, from the Apollo program, there's a lot of spin-offs, including, computers, laptops. That's like, you can't bring huge computers to space. Everything needed to be light, Everything needed to be small. Cameras, that's all from the space program. That's all from the Apollo era, like a lot of IT innovations, and then sunglasses, mattress, it's all part of the space program spin-offs.
Right.
Water filtration, air filtration, basically the recycling, because a closed loop system in the International Space Station, you have to recycle everything.
Right.
So, and in terms of, let's say, resource management, you can't, you're subjected to limited amount of logistics that you could bring in orbit. So you need to manage your resource carefully. That's why you also need to now start growing food in space.
Right.
And whatever that is also the mirror image of what we're experiencing here on Earth in terms of our resources limited. Land is obviously limited, and like how are we going to solve that problem as well? So that's applicable in our agriculture, for example. For fertilizer, well, we can't really bring fertilizer in orbit, so how are we going to create fertilizer out of nothing, right? And that could solve the problem of our fertilizer problem here, because there's a few countries that monopolizes fertilizer. So how can other countries be independent of producing their own based on the research from space farming, for example, right? So these technological spin-offs, that not all the AI and the technological stacks that thermal, for example, that's hugely beneficial for manufacturing semiconductors. So and that's what creates the value of the investment, because then it could work here on Earth commercially, right? And it could also solve the problem extraterrestrial. So that's why it's interesting. And it's like also a lot of the investments are now, it's actually in actually the building blocks of the technologies to enable living in space. Right? Because again, there's only certain limited amount of investments or investors who can support the upstream, right? And then but then if that problem is sorted, how can we then live in space? So that's where the investment opportunities coming in. So let's say we can get there. What are we going to do there? Okay, we need to build a base. How are we going to build a base? So you create the technology for that. And it's also, you can use it here, for example, building in remote areas, or navigating rough terrains, or underwater robotics system that can fix the subsea cables if there's something wrong for the gas piping undersea. So it's all highly relevant. And these spin-offs are or dual use is what makes it interesting.
Yeah, no, I think that's all very new for me, because I hadn't ever thought of space or the space economy or space technology in that sense of how closely or significantly it can impact how we live our lives here, and particularly in terms of technology and innovation and problem solving and so on and so forth. So you mentioned resource management, and you spoke about living on another planet or in space, etc. Where's that motivation, or what is our incentive? Is this like because we keep talking about obviously the limitation of resources on Earth. Is this kind of like our contingency plan? Are we going there for resources? What do we want from there? Is that going to be our plan B? What are your thoughts on that?
There's no planet B so far, as we know it. Even if there is, we can't go there. We can't get there. It's just, at the moment, we don't have a choice except Earth, right? But that doesn't mean that we don't explore, we don't try. We can do both at the same time as well. So obviously the spacefaring countries do focus on, space resources as a government. It's a long-term investment
Right.
for energy security, for example, and also the precious resources that is extraterrestrial, right? But technically speaking, is it possible in 5 years' time? I don't think so.
Right.
Again, relating back to the technicalities of things, that's a very long-term investment. But that's the beauty of why people in space are trying to do so, right? It's to, again, to give hope that if something happens here on Earth, then we probably have some people are working on an exit plan, Although the approach of, like, let's say, colonize Mars, and a lot of people are not happy with that approach.
Right.
But in the context of exploration and like pushing the boundaries, going above and beyond, and etc., and just seeing how far humanity can go.
Right.
And how much science, and what happened to Mars? Are we going to end up like them? Like the planet? So just how far we can go to learn what's surrounding us, and so that we know better about what's going on with us. Right? So, I mean, it's, again, very different from meditation, where you have to sit down and go inward and like, what's going on with me? Space is looking outward, it's going outward, but also to then understand what the space environment is, so that we also know what to do with ours, right?
I love that perspective.
Yeah, and like, I mean, from let's say the satellite observation, Earth observation, all the images and the sensors, then we know about our atmosphere, about our seas, about our ocean, about the land as well. So sometimes when you're too close, you can't really see it, but to map out like a digital twin of the Earth, to actually have a real time or near real time information of the status of the planet, that is absolutely crucial for defense or national security purposes. But at the same time, also, again, what would be the let's say climate disaster coordination or early warning system, right? So I don't know when the like if Mars going to be habitable or etc. Let's just get there first, and we're still there. So yeah.
And you mentioned that Indonesia was a leading player in the space economy or initiatives at one point in time. They were doing a lot of stuff. They're also very well positioned, I believe, when it comes to being on the equator. I think it helps them in some way. I don't understand a lot of that, but and a lot of your work also is really bridging the gap between spacefaring nations and emerging economies. So tell me a little bit about what's happening in Indonesia specifically, but then also what are the opportunities for emerging economies? Because of course there are competing priorities here, right? Like there's limited resources, there's so many problems to solve. How can focusing on this, like what are the opportunities there for emerging markets to leverage?
Okay. So for Indonesia, in the satellite communication industry, I think we're good. I think Indonesia actually owns a lot of the most satellite communication in comparison to other countries in the region. So a lot of the satellite professionals are always happy here because obviously we're a good market and we are a good customer as well. In other parts, for example, space exploration, there's not much. There's no activities on that front. The government does have a plan on having a spaceport. They want to build the Biak spaceport. And the equator, obviously, it's less force to go to, it's less G-force to go to space, and it's good for geostationary launches. But I mean, there are other options for that around the world as well. It's still, again, a very long haul project, although we've had offers. I mean, the government have had offers from other countries, so they want to invest in building a spaceport here, but it's not as simple as that, And there's also the question of like, what would be the opportunity for the private sector in that plan, right? Because to sustain a spaceport, that's like very tedious. A lot of there's an operator, there's a management, and there's the business side of things as well, right? So that's a long-term game, and which is still in progress, working a lot together with the government as well to build up the talent for spaceport, for example. And I don't know when that's going to happen.
Hopefully soon.
But I know Malaysia is highly committed in building their spaceport. So the government's very highly coordinated for that as well. So there will be some sort of competition, I suppose. But Indonesia at large, we have a sizable land, and we are geographically, strategically located, yes, in the equator. But we don't have rocket technology, which means that customers would need to bring in their rockets here, and there's the export control, and then it's not as simple as it is, right? So there's still a lot of complication that we need to sit down with the government and like, okay, how are we gonna, navigate this
and make it happen.
Yeah, and make it happen, and also how much investment, and there's no supply chain or ecosystem set to support that as well. So where do we start, right? You can't just have a spaceport without a supporting supply chain in place.
Yeah.
Because a spaceport is not just a launch, it's like a whole bunch of other things. So that's a lot. It's in the horizon, and it's in the national ambition,
right,
which we also try to engage, but one step at a time, I think, for that goal.
From our conversation so far, like I think one thing when it comes to particularly emerging economies that we might not have that kind of capital infrastructure or supply chain per se to invest in space technology. But one thing that really stands out is the need for human capital who can make things happen. And like you said, it sort of cuts across a lot of different industries and a lot of different domains. Can you walk me through a little bit in terms of, do you think that that's what I took from our conversation, but do you think that's a huge opportunity for emerging markets to leverage?
For Indonesia, I believe is human capital is the opportunity. There's a big generation gap between the Apollo era, between now and now. There's just a huge gap, whether it's in Europe or in the US. And that's why the industry is kind of like, it was a bit stagnant until SpaceX comes through. Again, the industry cannot grow without people, and they need people. So the way we see it, it's like there's about 65 million youth in Indonesia until 2035, 2040 something, the Indonesia Emas period. And it is a career opportunity. And we're trying to bridge that. But they need fundamentals. They need capacity building, for example. It's the same basic skills to go into any tech sector. It's STEM, even though it's STEAM. We also need the arts because policy is highly important as well. All these space sustainability, space debris, it's all policy, right? So that's the avenue that we see from engaging emerging countries. Apart from, obviously, we encourage to grow indigenous technology, because then there's for example, in Ukraine, when they had a war, they don't have their own satellite communication, right? So that event kind of it was a learning lesson. It was a learning lesson for a lot of government as well, that like, okay, if you don't have access to space, independent access to space, then if something happened, you don't have your own comm system, and
Right.
that's bad news for the entire country, especially for the
Right, yeah.
military. So yes, of course, we encourage the youth to build up upon technology, but again, there's a lot of restriction in it, right? Like, for example, I think if your country is not producing it, then you have to import all the components, and that's import tariffs is very expensive here. For
Right,
example,
yeah.
in Indonesia, it's not as simple. Like for rocketry, when we want to import, like we don't have rocket motors, or we need to import a lot of things, and that's going to be X amount in comparison to just buying things, or building your own will take time.
Yeah.
In comparison to like importing it, then you have restrictions as well. So that's the huge challenge, right?
But it sounds like a chicken and egg problem also, right? So, I mean, because one of the questions I was thinking is, yes, there are career opportunities, but I mean, even if I was to speak from the perspective of Pakistan, I mean, space might be an interesting career choice, but does it pay well? What are the opportunities? How do I bridge that gap between, okay, I know things versus now I have a career in space? Like, all those things are possibly questions for people which deter them from taking that route in the first place. So, do you think there's a way around it, or is it still good because there's going to be advancements and at some point people will be needed from emerging economies to fill that talent gap within the spacefaring nations? What's the solution, and should somebody actually take up that career?
Well, for one thing for sure, you have to be passionate to want to work in space. If you're looking for monetary compensation, there's a whole bunch of other industries that will pay you 10 times.
Right.
Probably. You can get paid well in space as long as you are in the right position. And you don't get to have that right position if you don't have the experience. So again, it's either you work up the ladder in any of the defense contractors, or you take and you swallow the pill and you do your startups and you fundraise and etc. You go through all that 7 years plus or 10 years plus, and you see where you're going. But the space is hard, like it takes a lot to sustain yourself in this industry. And if you don't have the passion, if you don't have the mental resilience, the perseverance, like forget it. You might as well
do something else.
So I find that like a lot of the people that I find in this industry is, first and foremost, they are passionate about it, and they're curious, and they love to challenge themselves. Like it's hard because there's not many people in this industry. It's still like the top, I don't know, maybe how many % of the world. You can't just pull a show, like people will find out about you as soon as possible. And so endorsement is important, and network is important, and building good relationships, again, international network, right? So but it comes back again to the individual. What is your goal in life? Right? Like, what is your purpose? Have you found your purpose yet? If you haven't found your purpose yet, then you probably have to do it like I did.
Yeah, the detour.
To go a lot of the detours until you're finally here, right? But even back then, I didn't know that my purpose would end up here. You see, so it's a lot of I think it's an individual's journey and its own. And if monetary compensation is highly relevant and very important to you, just go to banking. I mean, that's insurance, banking, that's safe,
Yeah.
even the IT or even tech is very unstable now.
Yeah.
You know, like there's the tech winter, there's the tech competition. I mean, we constantly struggle for talents because there's the tech sector, right? And people would want to go to AI because now AI is paying very well.
Yeah.
Right. So that's the
Keeps
growing.
changing. There's a lot of uncertainty there as well.
Yeah. But tech is a very investment sensitive sector where when the investors pull out and you don't have any more runway, then you gotta go.
Yeah.
You know. So again, it comes back to again the maturity of the individual. Are you seeking for experience? Are you seeking for I worked in, like a resume? Like I used to work here, I used to work there, and then. But in my case, as mentioned, I was in aerospace at one point, and then I was in climate change, right? But during like my time in aerospace, in that one particular company, it opened so much doors for me. You know, so I got the endorsement. Like once you were there, they knew you used to work there. You get to know all these top tiers people, and they are very helpful. They're very supportive because they knew that you made it there, and so you have that standard, and it opens so much doors. And it's not just for, and that's not even. I don't even look at it from a business. I get to know a lot of really amazing people in the world. You know, like very easy to work with. It's just so simple. Like I just give them a call and it's everything. We work very well together. And no matter how difficult, it's because we have all the same mental resilience, right? And we just maybe we love to torture ourselves as well, but just kind of like, okay, how do we solve this problem?
Yeah.
How can we push it one step at a time? And I have the support of my amazing friends and network, and again, that's something you cannot buy. All of these network around the world, like if I can go anywhere and I can call someone like I'm here.
Yeah, and it speaks also to your experience, but probably the hard work that you've put in as well, right? I mean, it takes time and effort to build that network and prove that you're worthy of that network. Like you said, right? It takes time to get to the point where you can make X amount of money, but also to have the support of amazing people. It takes time.
Yeah, but I mean, again, being in another industry doesn't guarantee you that as well. I mean, money comes, money goes, right?
Yeah.
Like business falls, business sometimes good, sometimes it's bad, you know? So it's just the wheels keep on turning around and around, and it just depends on where you are at that wheel at that moment.
Yeah.
But I also have another friend who he started in space, like in the US, government contracts and NASA and etc. But like he spent a lot of time there, and he did everything. He did the Pentagon, he did NASA, he did the whole 9 yards. But then he got dismissed because the project didn't continue. Then he ended up going to private sector. And he is very happy in the private sector because it pays good. And that's fine. But without having all of that, without having all of the space experience, for example, the industry experience, he wouldn't have that portfolio. Right, which not then enable him to go to the private sector.
Yeah,
I mean, it's all interrelated one another.
Absolutely.
And it still excites him whenever like he talks about space. And so it can go both ways. It can be like you're coming from a different sector with a decade plus experience or more, and then you wanted to shift. Like there are people that mid-career change as well. Like, okay, I'm kind of bored in this industry. I kind of want to challenge myself further. Then you make that shift. And other offers, they offer so much pay. But again, it comes back to
What
what
you
you
really
want and where you are in life. Is money important to you? Or are you seeking for the experience? I mean, astronomers, do you think astronomers get paid a lot? Not really. But
Really?
astronomers are the most, some of them are very, like, the most humble people, because they have the wisdom, right? Astronomy is a character building discipline. They just don't care about money, and they just they study it, they study the stars and etc. So some of them, money is not the goal.
Yeah.
Right?
And you might get to it at some point, right? It still takes time and effort.
May or may not.
Yeah.
That shouldn't be exactly, again. But once it hits you and, like, no, I can't do this, then you have the free will to change your course and see what's available for you out there. But and a lot, I mean, like, some people that I know as well, that they don't, like, even for myself, I try to balance myself between space and other terrestrial activities. I still find space to be the most interesting, to be the most challenging, especially because nobody's really doing it here. Not on the level that we do. So it is exciting, but it's also it has a lot of challenges. But yeah, I mean, that's something that we have to take one day at a time.
One of the things that the more we're talking about the space economy and exploration, I think there's also a lot of conversation happening around sustainability from that perspective, and their environmental concerns and space debris and so on and so forth. Is that something to be worried about?
Absolutely. I mean, the two biggest constellation now is obviously Starlink and the Chinese constellation, right? And there's going to be about 30,000 plus more, I think, satellites in the lower Earth orbit that have filed in the next decades to come. So it's going to be very crowded. It's already very crowded, and the debris are all over the place already, ranging from very small micromillimeter to a second stage of a rocket, like huge car sized, for example. And it can fall anytime. It can fall anywhere on Earth, right? On land and on the ocean. So that in itself is just like our waste management here on Earth. It has it even more further. It's the complexity of trying to clean up the debris that's traveling in a very, very high speed, right? Like many different sizes. It's more challenging than just simply cleaning up the ocean floor here. So there's the technical challenges, which some companies are working on it, like for example, Astroscale from Japan. And there's other ways as well in terms of, like, in orbits servicing, so refueling, extending the lifespan of the satellite. When you launch a satellite, you have the second stage, and you have all of these rockets, fragments that are not just floating in,
and that's
in
the
air,
primary
right? So that's
source.
That's a huge part of it.
Okay.
Rocket engines and rocket pods, like second stage. So there's that. And then also from the satellites, the orbiting satellites, the satellites that already no longer, and they don't burn up in the atmosphere, for example. If it's like, because not a lot of them, they're still floating over there, right? Or dead satellites, for example. Once you go launch, and then it's just, because not all spacecrafts that are launched are fully functional. Sometimes upon launch, it failed already. So they just stay float, right? So those are like, and then all of the collision, like for example, the ISS get hit by debris all the time, and that's very damaging. So all of these are accumulating, right? Which, just like waste on Earth, like you don't have clear access to space. It's going to damage other space assets. And what if it collides with the others, and that's going to damage other people's space assets, and that's going to affect the whole, again, system, right? Like our activities here on Earth. So There is the now the Zero Debris Charter by the European Space Agency, and there's a long-term sustainability policy. So a lot of countries are now trying to really, really hard to set up all these guidelines as to who's going to be responsible for what, and including what is space sustainability, what consists of a good design, so that it doesn't cause us, I don't know, debris, or it lasts longer in orbit, for example. There was an attempt of like manufacturing satellite from wood. So then once it's deorbit, it just burn at the atmosphere. Well, just a lot of them does, right? But there's still a lot of other things that are also just
And so
simply
the
floating.
primary sort of consequences can be, collisions in space, so satellites,
Yeah,
etc.,
for
that
sure.
impact our communication systems here, but also that those debris can fall anywhere on Earth. Is there anything else we need to be worried about?
No, the main is in orbit collision or conjunction, right? Because again, it's all traveling at very, very high speed, and even a small one can fracture your solar panel, for example, and that's
Right.
or it can change the orientation, right, or the orbit incline or whatever. So you need to adjust that, but that's like spacecraft operation mission. So that's why all companies that own space assets, or at least operators, they need space situational awareness. They need to have a system where they're like, okay, this is my asset, I have to keep it there, and like monitoring if there's any debris, and if there's any debris, then I'm gonna have to move it.
Right.
If it's a small debris or if it's a huge debris. So that's like a monitoring system on its own that everybody needs. And obviously when you're launching, like how you're going to navigate all of these waste, right? And it's just the whole again, sustainability as how we manage our waste here on Earth, but it's in orbit, which is much more difficult. In orbit collision and conjunction, that's very damaging to, and that's a huge threat for any space asset in orbit, especially if it's GPS or navigation system, right? If that's affected, that's gonna really impact a lot of the businesses here, logistics, for example, and then and it can fall anywhere.
Yeah.
But in terms of falling on Earth, we can't really help it because there hasn't been like a predictive modeling that's so accurate when and where, because there's just a lot of
have there been
factors.
any, like, in the past, have there been any damaging incidents like these before, and particularly in terms of
for
falling on
sure.
Earth? Were they harmful significantly?
Plenty.
Right.
Plenty. I mean, in Indonesia itself, it's like in Central Java. The SpaceX second stage fell here.
Okay.
A while ago, 2018, I think, 2019.
So when something like that happens, like you did mention, sort of, who takes responsibility? Like, who's responsible and who bears the damages, and like, how does that work?
So if an object, if a debris fell in wherever territory, like say for example Indonesia, right? Like there has been a few cases in South Sumatra, in Central Java. So they will try to identify, and if it's a space debris, they will try to identify whose is it, what is it, and whose is it. For example, it's SpaceX second stage. So we call SpaceX, hey, your stuff fell down here. Can someone collect it? Because simply, especially if it's US, then it's like it's theirs. We can't really have it, So they came here to collect it, and then they have to pay the fine.
Right.
It's just, like it fell on top of someone's house, and you're going to have to pay for it, and then all the cost related to it.
Yeah.
I believe it should be more than that, because then it's especially if it landed on the sea, right? That's already environmental pollution. But what else? Well, God knows if it's going to land in the middle of the street somewhere, right? But usually towards the coastal area or remote, you know, we do know roughly if the debris is coming in, because again, we have that space situational awareness. It's an open source. Everybody can access it. Everybody can learn how to identify and work on, let's say, predictive modeling to know when and where. So you can have like create an alert, early warning system, notify the government or the Air Force or the whoever, you know, that needs to coordinate at the field. Like for us, it's like BNPB. That's like Natural Disaster Agency. Right. So, but that's the only thing that you can do. You can just tell the government like, okay, there's incoming at approximately this time
Location.
at this coordinate, and you know, just vacate the area if it's populated, and collect it, and as soon as, and some we already know what it is, you know, so they would have to come and collect it, and there should be a fine. But that's the part where it's hard to reinforce that, whether if it's going to be the government or if it's going to be the owner of the debris.
Right. Okay, one thing that I'm just curious about, my last question, is you go for space advocacy. I'm sure you go to universities, you meet with young people, you talk to them about space. Are there any interesting questions that you recall? Like, what are some things that they're curious about?
Either they're amused or confused, but I hope they're inspired.
They're probably that probably explains me in this podcast situation, where I have so many questions, but I also don't know how to structure them right now in terms of there's so much to learn. Because it's a lot.
If you, again, and that's where we do our space advocacy in a way, like we try to demystify space. Like it's not an alien. It's not scary, you know. It's an industry like any other industry. It's just that it has a higher entry barrier, you know, not just intellectually, but technologically, right? But
perhaps even financially, right? Like you said,
yeah,
it's not.
Obviously. But it was inaccessible at some point because it was government-centric. It was all for military, right? But now, commercialization, and that enables the, let's say, the opening of things, right? This is like the Enlightenment period where, again, space education is part of the equity that we're sharing with the world, that, okay, these esoteric knowledge is now available. It used to be just government and military centric, but now we're open, you know, because we want to grow. If we keep it all ourselves, then we can't grow it, right? So in a way, it's like selling religion, because you're introducing new things to people who most of the people that I speak to, they always think like, oh, space is just so hard, and like it's just rockets, and
or don't believe entirely in the possibility, like, perhaps, or
and have that mindset of like, oh, why don't we just work on the problems here? Why do we have to go there? Right? So, and that's my job, and that's our role in explaining to people that like, this is why, and this is the relevancy, and this is why it should catch most of our government's attention, and how it can be beneficial for private sector in terms of just technological investments, right? That can benefit here, us on Earth, as much as it would be solving the exploration problem as well. You know, it's dual application. And that's the part where I think a lot of people take time to process, because again, it's like, oh, you're talking about the moon base and we're dealing with like remote area connectivity here, you know, like there's just, it's too big of a gap. That's why we're trying to close the gap. You know, because in the end of the day, this is all reality at the same time. Like, other countries are living in the future and we're still living in the past present. So how do we integrate that together, or at least those who are interested to be in the future can come and join us, and we'll introduce you to that
The
timeline.
fascinating world of space.
Yeah, and it's a lot of giving understanding and explanation of what the industry does, from because again, it's like, what do you like? There's a whole spectrum of where you can go, right? Like, you don't even have to be a technical person. If you're a non-technical, we need you too.
Yeah.
Like space communication, we need media and platforms to do our outreach and to explain to the public at large, like what I'm doing right now.
Yeah.
Right? So there's a place for everybody in space, and the industry is just like any other industry that needs multidisciplinary. I mean, like it needs sustainment from different skills.
Somewhere in your I read on your LinkedIn, you mentioned how you're very passionate about making space education accessible. It's a lot of the work that you do as well. Can you just elaborate a little bit on that and explain why you think that's so important?
Okay, so my perspective would be, I think space education is fundamental to any individual's existentialism, their perspective in the world. Like the solar system, it's very basic, and that's again, it's a knowledge that everybody deserves to know. It's the year 2024. Science education, space education is very fundamental. You need to know where you are. You need to know where you are in the universe.
Yeah.
And again, Earth as part of space as well, and what's going on with our planet, because that's all connected, right?
And so of course there's a very important role that schools and universities and these educational institutes play. Is there a message that you have for them in terms of how do they make space education more accessible?
I mean,
what
all
can
of
they do?
these space-related degrees or space education, they are mostly, again, abroad, right? In emerging countries. For example, even in Indonesia, there's only one university that offers aerospace engineering.
Right.
Let alone now, we don't, again, as mentioned, we don't need to be aerospace engineers to contribute in space. But, we can have STEM. But even then, STEM is still a very unpopular choice amongst youth here. And Indonesia is a country who needs a lot of basically scientists and engineers. Just, you don't even talk about space. We just need STEM people in general, right? Access to education, access to science education, access to space education that should be democratized. And it's also like a birthright, for example, to have to be given to students, especially in public schools. So I just want more university and schools to realize how important this is, And it's not about going to space, but it's about knowledge. Again, it's about science, the equity. I just came back from Sumba, and like I was teaching the first and second graders, and they don't know what planet Mars is. And it's the year 2024, So I think it's important to instill the sense of curiosity and hope. And these kids needs to know that there's other things out there that they can reach, and it is possible,
Yeah.
So it gives them the motivation and the hope and the curiosity, instead of just accepting where they are and not being inspired, because that's just, they're in a bubble. That's what they know, right?
Yeah.
They work in tourism, they work in hotels and hospitality. But I think, again, by providing access to space education, science education, STEM, that's what is going to help them realize that there's something more. In Indonesia, there's still not many support on that, because again, the mindset is like, why do we need to go to space? We don't need to go to space. We have a lot of problems here on Earth.
Yeah.
Right. And again, we have to demystify that mindset by saying like, it's highly relevant. Right.
And like you said, it's not also just about going to space. It's
Yeah,
that knowledge, it's that exploration, it's pushing yourself, like opening up your mind to other possibilities.
And how it's highly relevant to our daily lives here.
Absolutely.
Right? Like, do you teach them the Big Bang or do you teach them Adam and Eve? That's all day one. It's going to determine the kid's perspective in life, where he or she is. And, you know, do kids see the stars now? Do they see what's beyond? That's very... They don't even know how stars looks like probably in Jakarta, because you can't really see them, you know. So... But I remember when I was in high school and I saw the Milky Way, and that was the reason why I wanted to work for NASA. You know, like, it was just so unforgettable, and I would like to give that experience to kids here, youth. You know, like, that's your moment when you realize, like, oh wow, there's the cosmos, there's the universe. And because it's not just, again, about technicalities, but it's our soul connection with the universe as well, right? So I think that's important. And not only that, as a nation, you can grow from having science education as part of the curriculum, not because we need STEM skills in the future to come. Like, no country will succeed in any legacy without STEM skills. But it's also, again, to balance out that spirituality or religious belief that you want, that you have in your country. Like, for example, in Indonesia, we've got various religions here. But yeah, it's for the growth of humanity again, which I think is the most important thing.
Awesome. Thank you so much, Anna, for
No problem.
today.
Thank you so much.
I learned a lot.
Thank you. Thank you.
It changed
I hope
how I see, you know, the way we think about space generally, and what, you know, changed my perspective about it for sure. Yeah. So thank you again. And I hope to see you again soon.
Thank you. Thank you so much for inviting me and for watching. I hope everyone's enlightened. And yeah, I mean, don't forget to always look at the sky, and we're all made out of stars, and you know, stars are wisdom. So don't forget, you know, like, to look up,
appreciate the sky.
Yeah, and to look up, because that's where you will feel connected, not just within yourself, but also with the rest of the world.
Awesome. Thank you.
Bye.